Hello. Sorry, I'm setting a stopwatch because I want to make sure I don't cross more than 21, 22 minutes, and I got quite a bit to cover. So hope you don't mind. Oh, I've already spent 8 seconds. Oh, by the way, my name is Sosale Mohana. I'm a maths teacher who has taught A level for a long time, for over 50 years to be precise, and I am recording these lessons for the benefit of students who are doing A-level maths currently or those who might be doing it in the future to help them revise. Thank you very much. Let's get on with it. In the last lesson, we were in the topic on algebra and I was talking about infinite geometric series, and I had told you I'm going to write all these formulae I had written and left them. But I have added something else to save time. As I told you, I need to make up my own question. So let me read the question. A geometric series has a first term 5. So as I read, this is what you do in the exam. As you read, make your notes. The sum of the second and third terms, so u2 plus u3 is equal to twice the fourth term, 2u4. Find the two possible values of r. So we don't know the common ratio, so we assume common ratio equals r. Remember, the nth term is ar power n minus 1. Your a is 5, so it is 5 ar squared, ar cube, ar power 4, etc. That's your u1, u2, u3, u4. That's u1, that's u5, etc. So u2 is 5r, u3 is 5r squared, equal to 2 times 5r cubed. Remember, r cannot be 0, so, or even 1. So r is not 0, so they could divide by r. And I think I'll divide by 5r. So what do I get? 1 plus r equal to 2r squared, which gives you the quadratic 2r squared minus r minus 1 equal to 0. Remember, I told you, whenever you get a quadratic, don't substitute straight away in the calculator, get the answer and write it. Show your working. So 2r minus 1 and 2r plus 1 and r minus 1 is 0. So r equal to minus half, r equal to 1. So the answer for this is, let me use a red pen. I hope you can see red. R equal to 1 and r equal to minus half. R equal to 1 is not possible at all because it's a constant series. It's 1, 1, 1, 1, 1, 1, 1, 1, a. So it's not a geometric series, because remember, you're going to divide by 1 minus r. If it's r is 1, you're dividing by 0, and I spent a whole lesson teaching you what happens when you divide by 0. So r can't be 1. So the value of r is minus half. Anyway, state the value. So it was because I made up this question, it came out with a stupid answer, but that doesn't matter. R equal to minus half. Why? For sum to infinity to exist, we need the value of r to be between minus 1 and 1. So in the exam, you might get r equal to minus half and r equal to 3. R equal to 4 over 3. In which case you say minus half is acceptable, 4 over 3 is more than 1, so it's not acceptable. Then he says, find the sum to infinity. So that's your part B, r equal to half. That's for part A. Part C, sum to infinity, a over 1 minus r, 5 over 1 minus half. So 5 over 3 over 2, which is 10 over 3, which is 3 and 1/3. Many students write 3.3. Some students write 3.33. Someone 3.333. Very few write this. If you write that, that's good. Or at least write this. Or safer would be 3 and 1/3. Yeah, good. I wanted to save time. That's why I wrote the question before I started the lesson. Hope you don't mind, because I want to show you one or two more examples which come very regularly. The second example, which is actually you do it in a different way in GCSE and we do it in a different way at A level. I'll show you both so that you understand the difference. You see, for example, example 2, express 3.87 as a proper fraction, as a fraction in its lowest terms. Let me make it 0 point instead of 3. Let it be there 3.8, so it doesn't matter. So what did you do in GCSE? You called x equal to 3.87, 87, 87, 87, 87, etc. Your teachers have taught you. It repeats by 2 digits. So multiply by 100. What is 100x? 387.87, 87, 87, 87, 87, What is x? 3.87, 87, 87, 87, etc., etc. Subtract 99x equal to 384. 7 minus 3 is 4. So x equal to 384 over 99. Does this go by 3? It does. Why? 8 plus 11 plus 4, 15. So 3 1s are 3, 3 2s are 6, 3 8s are 24 over 33. That would be your fraction. So why are we doing this question? What's wrong with you? We're not doing GCSE. We already got our A star or 9 as the case may be. Why are we doing it? Hang on. But the question said using an infinite geometric series. Haha. Now what will happen? Express 3.87. Okay, suppose I gave this question in GCSE, will you be able to do it? No, that's why it is an A-level question now. So to understand this, we need to identify a series. So can I write this as 3 plus 0.87 plus 0.0087 plus 0.000087 plus 0.00000087 plus etc. So 2 decimals, 4 decimals, 6 decimals, 8 decimals and so on. So this is 3 plus 87 times 0.01 plus 0.0001 plus 0.000001 plus 0.1, 2, 3, 4, 5, 6, 7, 1, etc., etc. to infinity. I have got an infinite GP, not yet. I am getting it here. This is 1 over 100 plus 1 over 10 power 100 times 100 plus 1 over 100 times 100 times 100 plus etc. to infinity. First term is 1 over 100. Common ratio is 1 over 100. So therefore this is A is 1 over 100. R is 1 over 100. So S is A over 1 minus R, which is 1 over 100 over 99 over 100, which is 1 over 99. So it is 3 plus 87 over 99. That is 3 plus 87 is 29 over 33. So that will be 120, 33 3 is a 99, 119, so 128 over 33. You see, infinite geometric series. That's how you show it. In this question, if you're asked to use an infinite geometric series, otherwise, well, you would obviously use your GCSE methods. But as I told you, at A level, we call it as we ask you to use an infinite geometric series. I'm just taking one more example and then conclude this particular topic, which is, anytime, I'll write the question here. Anytime a rubber ball is dropped from a height h onto a horizontal floor, it always rebounds to a height how should I put 3/5? No, I think 8 over 9, 8 over 15. No, 8 over 9 is a big number. Yeah, 8/9 of the height through which it falls. I could put any number I want actually. So I'm just putting it as 8/9. I could make it 5/6. I think 5/6 is more decent, or 7/8. 7/8. Okay. A ball is dropped from a height. As I said, you don't have to copy any of these. You're going to get a handout. So a height of 10 meters above a horizontal ground. 10 meters is quite high, it's about 30 feet. That's the information. Part A says, find the total distance traveled Part A, when the ball is about to hit the ground for the 4th time. Part B, when the ball finally comes to rest. You're wondering, sir, where is this GP in this? Where is a geometric series? You're making up questions just to bug us. No, you'll see it. And people who are doing further mass mechanics, such questions are found when you have elastic collision. When a ball hits the ground, yeah, elastic collision will come across it because it's 0 less than e less than 1. That's right. Good. So let's understand the question. Look, this ball, let's say start from, even though it's going to bounce like this, for the model I have, I show each bounce separately. So it hits the ground here at the point B. All the points are going to be B and all the heights are going to be A, but I'm going to use different letters. So that is 10 meters. Now it will reach another point C. Actually, C is along AB, comes down. So this is the first collision. second time. And then it goes to D, then comes down. Third, it goes to E, and then comes down. Fourth. So I want to find AB, BC, BC times 2, let's say B1, B2, B3, B4. So I want to find that plus that plus that plus that plus that plus that plus that. So remember, it is jumping 7/8. So do you agree this is 7/8 times 10? So I can put it as the total distance as part A. I can 1, 2, 3, 4. So S4 equal to 10 plus 7/8 times 10 times 2 plus 7/8 of 7/8 times 10 times 2. So that's 1. Average here, and then 7/8 of 7/8 times 10, another 7/8 times 10 times 2, because remember 7/8, 7/8. This one again is 7/8, so that will be 7/8 whole squared and 10. That one will be 7/8 whole cube and then 10. So I just want to show you how it comes. So I can remove 10 as a 10 plus, I can remove 20 times 7/8 as a common factor. I get 1 plus 7/8 plus 7/8 squared. You can use a calculator and straight away find the answer. So I'll start from the other side. I need my glasses. Of course, I can use a sum of a GP. I don't want to waste my time. This is easier. 7/8 square, 7/8 times 7/8 plus 7/8 plus 1 is that, multiplied by 7/8 is that, times 20 is that, plus 10 is that. As a decimal, yeah, 56.21. Now is that correct? I hope it's correct. Let me use decimals because sometimes my calculator skills are not good. 0.875. So 1 plus 0.875 plus 0.875 squared equal to that, times 0.875 times 20 equal to that, plus 10 equal to that, 56.2. So 3SF, it's approximately 56.2. That was alright. But then it says when the ball finally comes to rest. So theoretically speaking, the ball is supposed to bounce infinitely many times. So in other words, if I continue from there, it's going to go like that. We assume the ball bounces infinitely many times. So the same series I'll continue. It is 10 plus 2 times 10 times 7/8 plus 2 times 10 times 7/8 squared plus 2 times 10 times 7/8 cube plus etc. to infinity. Remember, it's a geometric series from the second term. It's not a geometric series there. So your A is 20 times 7/8, which is 4 5s are 4 2s are 35/2 is 17.5. Your R is 7/8 or what is 7/8? 0.875. 0.875, which is less than 1. So 10 plus, find the sum to infinity, A over 1 minus r. So it is 17.5 divided by 1 minus 0.875 is 140 plus 10. So approximately 150 meters. Remember, theoretically speaking, the ball should travel 150 meters, but ball definitely travels less. Sometimes in the exam, they add a small jointer there. State two factors that might affect your answer, or they might say, in the real situation, will the distance traveled be less or more than the answer you have obtained? It will always be less because air resistance. So factors, if they want, the standard answer from mechanics, air resistance needs to be considered, and the mass of the ball is to be considered. Yeah, something like that. But fortunately, that's only way. In other words, they're trying to show that, look, this is a mathematical model. It has its limitations. So that, remember when I did geometric series, I said I'm going to come back to it. That's why I had to take it up here now. Okay. So we have finished geometric series. And when I said binomial theorem, I said I'm coming back to binomial theorem again. I said you will do another binomial series instead of binomial expansion. So that's what I'm going to take in the next lesson. See you in the next lesson. Bye-bye. Have a nice day. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.